This is how I would learn data engineering if I had to start over. In this video, I'm going to share with you a roadmap that I wish I had when I started my career in tech as a data engineer 5 years ago. The first thing I suggest you to learn is Python, high-level dynamic programming language that is widely used in the data industry. Almost everyone who works with data uses it, and specifically data engineers, because as a data engineer, you'll build tools to build data pipelines, and often Python is a go-to language to build it because it's clean, it's simple, and you can develop very quick with Python. Next, once you know the fundamentals of Python, I mean like basic programming language, and you're comfortable with it, only after that you should start learning data processing library like Pandas or Polars. Both of them are very nice. Pandas is like an older library that exists for a long time that has a huge community, a lot of services already use it. Polars is a little bit newer, but yeah, kind of faster than Pandas and like the cool kid on the block. So I would say feel free to choose whatever you like, and both of them will deliver what you need at this step. At this point, we have two branches how we can go. We can go left and learn about distributed compute and big data. And as a specific tool, we can pick Spark. Or we can go right, learn about SQL and databases. Here, I would leave this choice to you because both paths are fine. Yes, I have my preference. For me, it's SQL plus databases. For SQL point, just learn the syntax, practice a lot to exercises, watch tutorials. There are tons of them. And yeah, just get good at it, at just querying the data with SQL. Good enough at SQL, at like solving some tasks with it of querying data. It's time to learn about databases. Learn about relational databases, NoSQL databases. What are the differences between relational and NoSQL databases? Why would you choose a relational database in this situation and why NoSQL database in that situation? Data modeling in RDBs, like relationship between tables, one to many, many to many, and so on. Normalization, data integrity, all that kind of stuff falls into the databases section. And this is a good point because it's a strong foundation that you need 100%. It's time to learn about data warehouses. What are data warehouses? Why do they exist? What types of processing exist? Online transactional processing, OLTP, versus online analytical processing, OLAP, and this is tied directly to the concept of data warehouses. Just to drop some names here, the data warehouses that are popular now and that I have used personally a lot are BigQuery from Google Cloud and Snowflake. So yeah, just pick any of them and play around with them. And the next step in this branch is actually the first step on the left: Spark, distributed compute, and big data. With data warehouse, you learn that you are able to process vast amounts of data, but you might lack some theory about how does it actually work, why data warehouses are able to process these amounts of data. And this is tightly coupled with distributed compute, because distributed compute is actually the reason why data warehouses and why technologies like Spark are able to process huge amounts of data and what we call big data. So here you will learn the theoretical concepts like master-slave architecture, about distributed storage, about distributed compute, about scaling, vertical and horizontal, and how does it actually work. Now I'll open the left side, and as you can see, it has the same blocks as the right side, but just arranged differently. And this is why I was saying that it's fine. It doesn't matter which side you choose, just a different order. So my preference was this order, but it's absolutely fine if you go, if you choose the approach on the left.